All right. Thanks, Greg. I want to make sure everyone can hear me. So if in the back, if you cannot hear me, just start waving your arms like a crazy person. As Greg said, I am in the Netherlands now. I live in a town called Nijmegen, which is over by the German border, but I work in the Amsterdam office of a agency called Bakken & Beck. If you're interested in learning more about that, come talk to me afterwards. Now, before I start, I really just wanted to say merci pour m'inviter au Paris. J'ai étudié français dans mon lycée, mais j'ai oublié beaucoup dans les 20 années d'après. Aussi, ma français pour technologie était limité au où est mon ordinateur. Et pour ici, ça c'est pas bien. So I will be doing the rest of this talk in English. So, raise your hand if before tonight, you had heard of Kotlin. All right. Pretty much everybody. And raise your hand again if you work with someone who uses Kotlin. A lot of people. Okay, how many people here have actually tried to use Kotlin themselves? Okay, a few fewer hands. I want to try to catch up anyone who's not familiar before I go too far into everything. Kotlin's a relatively new language that primarily runs on the Java virtual machine. And it was created by an independent builder of integrated development environments. It's called JetBrains. As Swift developers, you probably know them as the people who build app code, although you might recognize them a little bit better from the old app code logo, which actually made it a little clearer that it was for use with Apple technologies than the current logo does. And JetBrains makes a ton of other IDEs, including stuff like ReSharper and RubyMine and PyCharm and PHP Storm. But all of these IDEs are descended from a single IDE, and that is IntelliJ IDEA. This is JetBrains' Java IDE, and IntelliJ's core is open source, and it has both paid and free editions, and IntelliJ has done a ton to move Java development forward over the years. So JetBrains believes in reusable code, so they've used IntelliJ as the basis for all of these other IDEs over the years. And since IntelliJ was built in Java for Java development, the JetBrains team developed this really deep knowledge of the advantages and disadvantages of Java. So when they decided they wanted to write their own programming language to take advantage of a lot of modern language features that Java could be somewhat slow to adopt, they decided that they wanted to write a new JVM language. Now, this wasn't a totally insane idea, because for years, languages like Clojure and Scala and Groovy had already been built on top of the JVM. So none of those languages had the features that JetBrains wanted, except for Scala, which particularly around the time that Kotlin was first created in 2010 was known for its exceedingly terrible compilation times. So they decided to build a language with all the features they wanted and decent compile times, and they named it Kotlin. So what is Kotlin? Well, first I'll give a quick primer on what it is named for, which is an island near St. Petersburg, Russia. And if your geography of this area is a little bit rusty, St. Petersburg is way up in northeastern Europe, and it's not too far from either Helsinki, Finland, or Tallinn, Estonia. The builders of Kotlin have said they wanted to name their language after an island because Java itself was actually named after one of the main islands of Indonesia. So, as a room full of Swift and iOS developers, most of whom are not from St. Petersburg, you're probably asking yourselves, why on earth should I care about Kotlin? What does this have to do with me? And one big reason, if you work with a cross-platform team, is that it makes it quite a bit easier to communicate with your Android team about the code that you're writing and share some basic thoughts, architecture, and logic. Because Kotlin has so many features that are similar to Swift, it suddenly becomes much easier to compare logic with your Android team than it was when you were working in Objective-C and they were working in Java. So how similar are these languages? Let's look at a few examples. First, how do you declare a string which is assigned once and never changes? I think you're all familiar with the Swift syntax, let greeting equal hello world. The good news is that other than the Kotlin equivalent of let being val, this is identical. That's awesome. So how about declaring something that may or may not be there, but if it's there, it's an integer. Again, pretty familiar Swift syntax, and this time even better, the Kotlin equivalent of this is exactly identical. Like Swift, Kotlin brings native support for optionality to a major platform for creating mobile applications. And being able to have optional support was a particularly big win for Java developers, since it could be used to drastically reduce the number of null pointer exceptions. So You know how annoying it is when you're working in Objective-C and you have something nil and you try to shove it into an array or a dictionary and then it crashes? Imagine that with anything that's null. So where Objective-C no-ops method calls on objects that aren't there, if it's not trying to stick something into an underlying C object, Java will throw an exception on any attempt to access a null pointer, and if it's not caught, it crashes your process and your app. So as much help as optionality has been for iOS developers, it has been huge in terms of reducing bugs caused by null pointers, a complete game changer for Android developers who have been writing in Java. So another way in which Kotlin is very similar to Swift is that it has both generics and functions as parameters. Java already had generics, so in this case, Kotlin is mostly just maintaining existing functionality. But being able to pass functions as parameters to another function is new and lets you do some really interesting stuff. In Swift, you can use generics to say you want to apply a function to anything, and it can be used pretty easily by passing in both the thing you want to apply the function to and the function itself into the same method. Because you're able to actually create an extension function very similar to a Swift extension on a generic type, you can now call this method on any type and apply any function designed to return any other type. So this language feature allows the use of some of the same major functional collection methods like map and filter and reduce. The map and filter operations in Kotlin are exactly the same as they are in Swift. Map operator takes a collection of things, takes a passed-in transformation, and it applies that same passed-in transformation to all of the things. And it returns a collection of all of those individual operations. Filter operator checks each thing in the collection against a passed-in Boolean function, and then it returns of anything that passed that function with true. Now, reduce is somewhat similar. There's a small, really annoying distinction where to get exactly the same behavior as Swift, you have to use a different function. So in Swift, when you reduce the contents of a collection, it applies whatever function is passed in by taking in the accumulator, the start value of which is passed in as the first parameter, and then the reduce operator is passed in as, the function is passed in as the second parameter. So I really actually kind of hate this syntax for the function. It's also not really something that's available in Kotlin, so I'm going to make it ever so slightly clearer that things being added are the first and second parameters being passed into the closure. And in this case, when you've got an initial value of 0, adding each number to an accumulating value of the other numbers winds up being 6. But if you want to start somewhere other than 0 or a similarly empty value for whatever you're reducing, you can do that easily by changing the initial value. Here I changed it to 20, so now the result is 26. So you're probably familiar with that part. But when you go to use reduce in Kotlin, it turns out the reduce function has no initial value. It just always starts with an empty of whatever is expected to be returned. So a 0 value for integers in that case. So what do you do if you actually want to use the initial value that you're passing in a parameter when you're working in Kotlin? You actually have to call a different method, and that method is called fold, because why not? And you can see at the end, this does exactly the same thing. Now, you may notice that Kotlin also does a couple of things slightly differently when it comes to parameter placeholders for functions. In Swift, we use the $sign and the parameter index to indicate what parameter we're trying to access. In Kotlin, if you have a single parameter, you use the it keyword. And this always makes me think of the Stephen King movie, It, but with the clown trying to get me to use Kotlin. And just as there's only one insanely creepy clown in It, you can only use it to either represent a single parameter or a tuple of all of the parameters being passed into the function. Anything beyond that, and as you saw before, while you can use multiple $sign parameters, just building up as many dollars as you can with Swift, in Kotlin, you might have noticed earlier, if you want to access more than a single or the entire set of parameters as a single blob, you actually have to break it into multiple variables. So there's more than a few of these little annoyances, but for the most part, Kotlin code and Swift code can look extremely similar. And all of these similarities can lead to better communication between you and the folks working on your Android application. You'll be able to look at their code, and despite some of the differences in view, lifecycle, and architecture, you'll be able to have an idea of what it's doing way faster. And the same goes for Kotlin developers looking at your code. A fun side effect of this is that you become much more able to talk about common tooling and architecture ideas. And in addition, no platform or language does everything entirely right, but the more you learn about how other people tackle the same problem, the easier it is to steal some of the best techniques and tools for your language. Now, there's two things, it's actually four now, one for each language, that I think the other language could benefit from stealing. And the first is that Kotlin should totally steal Swift's guard syntax. There's currently a syntax for dealing with optionals that does only do these things if this thing actually exists, which is a let instead of val to unwrap, because I guess Kotlin designers wanted to make a distinction with the operator and the keyword. Either that or making it val would just be too simple. But if you want to add an else clause to a let so that you can do something if the variable isn't there, well, too bad, because that's not actually possible with a let. So then you have to fall back to checking nullability the old-fashioned way. And then having the compiler magically allow you to use the variable without force unwrapping if you find the object to be non-null. Also, fun fact, Kotlin force unwrapping requires 2 exclamation points instead of 1, just to really underline the idea that force unwrapping things is a terrible idea. I really personally like Swift's if it fails bailout model, and I find it easier to read. So I would be happy to see something like this come to Kotlin. Now, a nice thing in Kotlin, which I think Swift should steal, is the apply function. Right now in Swift, if you have a single instance of something, especially a singleton, which you want to apply multiple things to, you either have to access the set singleton in full for every single action, or pull it out into a single variable, then repeatedly access that variable. What the apply function in Kotlin, as I would propose it be stolen by Swift, would allow you to do is set values in a single closure on the given type. It's a little bit of an adjustment reading things this way, but once you make the adjustment, this can actually be super, super helpful. So what about other thievery? I think that Kotlin should definitely steal protocols with default implementations. Now, as mentioned earlier, I did a whole talk about this in January. I'm not going to bore you because there's like 18 minutes of me yapping about why I love protocols with default implementations already. Go watch the talk. There's a link at the end of those slides if you're interested. The key thing I want to be able to do in Kotlin is to be able to say that when I declare an interface, which is the equivalent of a protocol in Swift, that I can also create some kind of default implementation for it to work. Now, you can sort of do this with a JVM default implementation. There's more of a Java feature than a Kotlin feature, and it's really not implemented very well. So I'd really like to see Kotlin steal that idea wholesale. Finally, I'd really love to see Swift steal the concept of sealed classes. So a sealed class is this weird combination of an enum and a final class. It's basically something where you can only create subclasses of a given class in a particular file. If you try to subclass outside that file, you get a warning. For example, if you were trying to model a view that either has stuff or shows an empty view, you could create a sealed class which contains subclasses which represent the possible states, which have properties for the data associated with them. You can then use a when statement, which is similar to a switch statement in Swift, to exhaustively go through the possibilities and be able to handle each of them as it shows up. You can achieve something very similar in Swift by using enums with associated values. But there's some neat tricks that you can do with sealed classes that are just not possible with enums. For example, you can take your sealed class and give it additional properties and functions which only make sense for one of the subclasses. You cannot do this in Swift. You can't add additional properties beyond the associated types, and you can't add computed properties that only apply to one case and not the others. This is really, really useful for modeling complex state and unidirectional data flow. I can speak English. And there were 2 really, really, really outstanding talks about this at this year's Kotlin Conf. I've thrown links to them at the end of the slides as well. If you're interested in this whole idea, those are much more conceptual talks, and even if you don't understand Kotlin, they're super useful. I would really love to see something like this come to Swift, because as much as I love enums, I think you can do some even crazier, cooler stuff with sealed classes. So everything I've been talking about so far has been about the primary version of Kotlin, which is the one that runs on the Java virtual machine, and therefore has access to tons and tons of stuff in the Java language. So what if all of this sounds good, but you really do not want to deal with Java or yet another layer between your code and the hardware it runs on? Good news, you do have a few options. Kotlin already has functionality to allow it to be cross-compiled into JavaScript. The idea is similar to TypeScript in that you want type safety without having to give up the wide array of libraries that you can take advantage of in JavaScript. But I know that people hate JavaScript almost more than they hate Java. So the thing that would be of far more interest to you as Swift developers is a thing called Kotlin Native. So Kotlin Native is an experimental program that's recently been promoted from an early access preview, which is the functional equivalent of an alpha release, but it sounds a lot cooler. And now it's in an actual beta. And it's made some really, really impressive improvements in the last few months. So I want to take a look at what it actually is and some of the stuff you can do with it. Because especially when iOS devs hear the word native, they start thinking, oh, come on, yet another thing that wants to let you write once and run everywhere. Have we not gone through this before with PhoneGap and Xamarin and Titanium and React Native and all the other ones I cannot even think of to let you write extremely terrible code for both iOS and Android? The difference with Kotlin Native is that it allows Kotlin code to be compiled into LLVM bytecode, and from there into machine code. And if that abbreviation sounds familiar, that's because LLVM is the same compiler used by Swift, and it was built as the graduate thesis of some guy named Chris Latner, who you may know better as the inventor of Swift. Fun fact, LLVM was not his PhD thesis, it was his master's thesis. Every time I am reminded of that fact, I feel 5 years older. Anyway, what it means that LLVM is being used to compile Kotlin is that the compiled code can run directly on various processor architectures without the need for a virtual machine. And what that means is that code compiled from Kotlin could be optimized for particular architectures in ways that are just not possible with the JVM. Because a ton of architectures are supported out of the box by LLVM. That means that Kotlin Native can also support a lot out of the box. They don't support everything LLVM supports. The list of supported platform is growing. WebAssembly is a brand new addition to that list and points to the long-term ambition of Kotlin Native. So clearly, JetBrains wants to turn Kotlin into a language which allows for shared modules across many different kinds of architectures. To help facilitate doing all of this, JetBrains built a plugin and a build system for IntelliJ and Android Studio, which helps abstract away a lot of the inconveniences of making all of this work. They called it Conan with a K, just like Kotlin, because they really love consistent branding. And this plugin can create executables or either a static or dynamic library with C headers for C and C++ projects. But most importantly for us as iOS developers, can generate a Cocoa framework compiled with the very same LLVM compiler as Swift and Objective-C, which you can use in your application. The news, not all good here. There's some dynamic features they're taking advantage of to make all of this work, which means that all the interface code which is generated is in Objective-C, which can feel a little bit like Objective-C dressing up to fit in with the Swift kids. But there's some really, really neat stuff you can do with this, particularly because you can expect fun. Actually, this is a keyword in Kotlin Native, which allows you to say, I expect that there will be an implementation of this function for all platforms this project supports. So you can say in your Kotlin Native library that you expect each platform to show its platform name. And then you can look and see what the implementations of the functions are per platform. If you pick the iOS implementation, you can see that it actually imports platform.uikit.uiDevice. That's because Kotlin Native uses generated Kotlin wrappers for everything in iOS. Some of them work pretty well. For example, when I was messing around with styling in Kotlin Native, I was able to create a sealed class that I declared in Kotlin that had all this information about types and sizes for various fonts. And then I was able to create a way in Kotlin to access these UI fonts using these sealed classes. And that allowed me to do that at the Kotlin Native level, so that when I was actually running on device, Android and iOS were able to use the same information to display different text, but in the same font. Now, I have to note that there are some weirdnesses to the interop stuff, because while this stuff can work pretty well, it also isn't entirely ironed out. especially in terms of getting Objective-C types that play well with Kotlin types. For example, I had something where I wanted to take data and convert it into an NS string. That's a fairly simple thing to do using a foundation API in Kotlin native. The problem is that I then needed to deal with that result as a Kotlin string. And while most things in Kotlin native are automatically bridged to Kotlin strings by the compiler, this create API actually returns an NS string type. So I figured out, okay, do an optional typecast. Again, same as in Swift. Unfortunately, I also got the compiler yelling at me, same as in Swift, that cast actually can never succeed. So I did find a workaround, which is that string by appending string somehow returns a Kotlin string, so I just appended an empty string. I was not particularly happy about that, warning, awful hack. So I tweeted about it, and someone pointed me to the documentation for an existing API to change NS string to a Kotlin string. And one of the things that you might notice at the bottom here is it's been deprecated because you should be able to just do a straight cast of NS string to string. So like an idiot, I went back and I tried again, and I got exactly the same error message as I got before. It's good to remember that Kotlin Native is a very experimental project, and even when the documentation says, yes, this will totally work, you can still find out that the compiler is on a totally different page than the documentation. But again, there's some super neat stuff that's going to be possible with this, most of which comes in the form of centralizing your business logic. The bits about what data you want to get in display, not necessarily about how you want to display it. For instance, if you've got a set of hours of operation for a business, you can set up everything from that object to be able to display it on iOS or Android within the Kotlin native library. Then, when you're displaying the hours of operation on a particular platform, all you need to do is take the string and show it to the user. Each individual platform has to have its own way to do this, to figure out how to do this, but now it can easily be done. Now, I mentioned a couple of things that are a little rough already, but again, this is an experimental feature. There are a few gotchas to working with some of this stuff right now. Kotlin native tooling is kind of terrible. To do it right now, you have to use Kotlin 1.3, which I believe was only released this week. You can also run into issues where a library that you want to work with only depends on a very specific version of Kotlin or a very specific version of Kotlin native, and those may not necessarily be entirely compatible. It's a lot better than it was about 8 or so months ago. There are still some serious problems, one of which seems kind of difficult to solve without throwing a new computer at the problem, which is that trying to run 2 IDEs at once, especially Android Studio and Xcode, will make your computer very, very sad. Your fans will spin up and your laptop will sound like it's trying to launch to the moon. The spinning beach ball of death will become your best friend. If you have a brand new 2018 MacBook Pro 15-inch with 32 gigs of RAM, this might not be a problem for you. Everybody else, it's kind of going to grind. So be aware of that. If you have a new computer, good for you. Otherwise, can't get slowed. Another thing to be aware of is that you have to work with a brand new concept of memory management and concurrency, because while Kotlin as a language has recently added coroutines to its bag of tricks, which are really neat and worthy of a whole talk in their own right, in Kotlin native right now, they only work on the main thread, which basically means they don't work at all. So you have to use something called workers. And I'm not going to get too much further into this because it's going to get really deep into the weeds really quickly. But suffice to say, it's a really odd combination of coroutines and arc, and it can have a pretty steep learning curve. And if you're not a fan of getting chocolate and peanut butter or other crossovers, bad news. It is way easier to use Kotlin native in a mono repo, a single repository for all of your Kotlin native Android and iOS code, and potentially for other code in your project, which can take advantage of Kotlin native, such as backend code. Now, you can see an example of what this winds up looking like at this URL, where I've been futzing around with Kotlin native for fun and or profit. Having everything be able to quickly rebuild is critical for fast iteration across platforms, but particularly for things like code review, it means everyone gets to listen to everybody else shouting at each other. Yay! With a big project, that's going to be really annoying. It's not that bad when it's just me shouting at myself. But there's another thing that people are used to in Swift. It's very buttery smooth. The other thing that you get to go back to is some Objective-C interop hilarity. So remember when I mentioned all the code for the Kotlin native framework is accessible through an Objective-C header. That means you lose a couple of features from both Swift and Kotlin. For example, Swift enums are a great way to declare an exhaustive list of classes. And while Kotlin has sealed classes for super advanced work, they also have enum classes for things which are far more similar to what you would do with Swift enums. So let's go back to this screenshot that I had earlier, which turns out is what gets generated when you have the header for a Kotlin enum class in a Kotlin native framework. So there's a couple of key things to notice about this code. First, this is a class that has had subclassing restricted. It's not even an NS enum that allows easy interoperability with Swift. It generates enum-like syntax and behavior by using class properties on the generated class. So you can still create a switch statement, which looks very similar to a Swift enum switch statement, but because this is using a class instead of an enum, it's actually using pattern matching under the hood. And therefore, it's not able to determine whether this switch actually handles all of the possibilities, which is generally the entire point of using an enum or an enum class. You probably have to go back to something that you used to do in Objective-C, which is add something which crashes super loudly when an unhandled case is hit, so you can at least find out what the problem is at runtime. I've been tempted to try to work around this using code generation, but the idea that that workaround is even necessary is really frustrating. And you know that when you're frustrated, you often turn to the documentation to see if maybe there's a better way for you to do something. And because Kotlin native is still in beta and having changes on a fairly regular basis, there are definitely a lot of places where there just is no documentation whatsoever. Or as I mentioned earlier, there can be flat out wrong documentation for what you want to do. However, as developers have been beating their head against various walls, the Kotlin native team has been working to improve the documentation, and I can confirm that it has made substantial improvements since the last time I looked at it before the first time I gave this talk in February. The Getting Started guide is a particularly huge improvement. I went from unsuccessfully fighting with the Kotlin native project for literally days to actually getting something up and running in about an hour and a half. So please bear in mind that this is a technology with a ton of potential, but it is not quite ready to use in production unless you're really willing to take a risk. The one thing that Kotlin native means is that despite everything I said earlier about Kotlin being born on the Java virtual machine, you can now choose whether you want to use Kotlin with or without Java. And I suspect most of you, if you have the choice, would go with without. So if all of this has gotten you interested in working with Kotlin, there are a few places that you can get started. The first is an online sandbox called trykotlinlang.org. It allows you to create some very, very simple Kotlin code and then lets you mess around with it a little bit and see how your changes affect the output. There's also an EDU tools plugin for IntelliJ or Android Studio. Both of these have a free version, and you can try out the EDU tools plugin. You install it through your IDE. It gets special treatment because it's a plugin that's actually created by JetBrains. Once it's installed, you can download a course called Kotlin Koans, which is really great because it's baked right into your IDE. You don't have to worry about the internet being flaky or anything like that. Having the ability to just randomly mess around with this stuff is super fun, and it encourages you to explore. So now, we've come to the obligatory summary slide for this evening. Remember that Kotlin allows you to literally put the fun in functional programming. If you are tired of just typing that extra C at the end of every function declaration, you are going to save so much time. Kotlin allows you to be friendlier with your Android team. You can share your joys and your triumphs along with your frustrations and tribulations, and you can trade stories of what works and what doesn't in each language so that each team can learn from the other. And while Kotlin native is super, super cool, it's not quite ready to be used in the real world. I'm really, really interested to see what it says about the future of Kotlin as a language, which is potentially fully independent of the JVM. In the end, my advice really boils down to one thing. Give Kotlin a try. Though, since this is a Swift meetup, I do have to pay homage to Steve Jobs and announce one more thing, which is naturally a completely shameless plug. I've done a ton of writing for RayWenderlich.com in the past for iOS stuff, but if you are interested in learning more about Kotlin, you'll be happy to hear the tutorial team has been branching out. We have 2 new books with tons and tons of Kotlin, both of which that I participated in. I'm one of the co-authors of Kotlin Apprentice, which is entirely language focused. It's a great way to start with Kotlin from as low a level of knowledge as what's a computer, and going all the way up to introductory use of coroutines. Experienced Swift developers can probably skip the first few chapters, but it does ramp up in difficulty pretty quickly. I'm also one of the tech editors of Android Apprentice. It's an introduction to Android development using entirely Kotlin and going from a basic Hello World app all the way up to some pretty complicated stuff using live data and Android's built-in flavor of MVVM. And avec ça, je vous dis merci. I won't keep you guys too long, but I'm going to post these slides that have all sorts of links and 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 links, and also this lovely illustration. But yeah, thank you very much.
Questions?
I think the first question is, can we eat pizza?
Yep.
Did you try to, because I saw that Swift is mostly on Android. Did you try something on that to do some cross-platform?
So I have not tried any of the Swift flavor that works on Android, partly because I think the big difference with Kotlin native and the stuff where Swift is running on Android, the stuff that allows Swift to run on Android is basically the work of like 1 or 2 people who did it as sort of a like, hey, why climb Mount Everest? Because it's there. Kind of thing. And it's not something where Apple has any sort of inherent, they don't really have any inherent interest in keeping that running. JetBrains, on the other hand, is really going all in on this because they basically see it as a way to have Kotlin be like this world-dominating language. And it's something where the value proposition is very different because they're not actually like the company that's making the phones and things like that. So it is something where they have the ability to say, hey, we want to make this truly a cross-platform language in a way that I don't think Apple has the same incentive to. But that's a good question. It does seem like it's a giant pain in the butt to get the Swift Android stuff up and running from what I've read. So
That's what I saw.
yeah. Yes.
Did you experience any increase, because of Kotlin would bring, like the runtime, or have you experienced like any overhead in size?
So it doesn't actually bring its own runtime. It compiles everything down into the LLVM bytecode, which runs on machine code. So it actually uses the Objective-C runtime, which is why all of the headers are in Objective-C.
But like for the coroutine, for instance.
So I did not really try using coroutines on Kotlin native. Again, they basically don't work on it. That's something where I think that's going to be a much harder transition. The stuff that they've got in terms of workers and some of the stuff in terms of basically being able to say, okay, I want to spin up an arbitrary number of threads is really interesting. But it's a steep, steep learning curve. So I'll be interested to see if they can figure out how to make coroutines work on native.
And what about the standard library?
Standard library works completely without the JVM.
So it's embedded in the file.
Yeah, it's basically anything that you can compile from the Kotlin standard library will run on iOS without a translation layer.
So it does come with an overhead.
I said without a translation layer. So I haven't done a whole lot of testing in terms of performance to be able to tell you, okay, this is where the performance gets a hit, or this is where it doesn't. But I've recently worked on an app that has sort of like a JavaScript sort of brain to try and do the same thing in terms of centralizing the business logic, and I can tell you it's night and day in terms of how fast everything is.
The reason I ask for this is because we have we do the sort of same thing, but not with Kotlin, with Go.
Yeah.
So we embed the entire Go runtime as a dynamic library inside the application, and it does come with an additional overhead of like 5 or 6 megabytes.
Yeah.
So,
So in theory, so my understanding of how this works is that because it's all actually using the Objective-C runtime and compiled down into LLVM bytecode, it does not need any additional, it doesn't need any additional runtime stuff to be able to run normally. I can take a look later when we're done about like how big the actual library is, but my recollection is it's really not that big a change.
Another question?
The first example you made was the strings.
Yeah.
Did you make? I noticed that you maybe use it for business logic.
Yes.
But is it possible to have a single UI, for example, mocking or prototyping?
Yeah, I mean that's definitely something where depending on how much work you want to put into it, you can sort of make these structures that are reusable across platforms, but that does require more work. There's not really there's not like a built-in UI layer to Kotlin native. All that stuff that I showed you with the strings and the fonts and all that stuff, that's all stuff that I like personally got to build, which was fun because that's a hobby horse I've been riding for a long time. But it's definitely something where the potential for libraries around that kind of stuff, the potential for time savings on that stuff is really pretty huge. And it would be, again, because Kotlin native can also get cross-compiled down into JavaScript, you could theoretically have something where you have some form of layout sort of setup that works on iOS and Android and web. So could be pretty cool.
Mm-hmm. That's quite awesome.
Yeah.
Thank you, Ellen.